The purpose of this presentation is to review the diesel particulate filter, DPF, cleaning procedure for all DTNA vehicles equipped with an after-treatment system. We'll draw a comparison between the DTNA approved solutions and the process used by aftermarket companies and show why the DTNA solution is far superior. First, let's briefly review how the DPF filtration system works. Over the course of time, particulate matter slowly accumulates within the DPF. This decreases the efficiency of the DPF, increases back pressure, and adversely affects fuel economy. At this point, depending on the application, up to 2 inches of particulate matter may have accumulated within the filter. A vocational or city-type duty cycle would accumulate 3 inches of ash loading at 300,000 miles. This is represented by the red dotted line extending from the 0 point to the 300,000 mile mark. A line haul application duty cycle would accumulate 3 inches of ash loading at 400,000 miles. This is represented by the red solid line extending from the 0 point to the 400,000 mile mark. As a function of the duty cycle, a check engine light will be triggered by code 3720-15. This fault indicates that the diesel particulate filter has reached the end of its service life and must be replaced. The ash accumulator is then reset using diagnostic link. If this visual warning continues to be ignored, DPF overtemp codes will be triggered, indicating a level of 4 to 5 inches of particulates in the filter. This potentially leads to permanent damage of the DPF and can cause failure in the SCR catalyst. Important note, for EPA 07 DPF units, the ash accumulator is based on mileage. For EPA 10 and GHG 14 units, the criteria is fuel used or mileage. When the check engine light is first illuminated, triggered by code 3720-15, the diesel particulate filter must be serviced in accordance with the guidelines detailed in Service Letter 14TS14 Rev. If replacement of the filter is necessary post-inspection, the customer has 3 options: an aftermarket cleaned unit, DTNA's reman filter, or a new filter. Option 1 is a process referred to as the bake and blow method. Essentially, this process involves heating the DPF filter to a certain temperature and forcing air through its chambers to remove the loose ash. The service time required to complete this process ranges from 4 to 12 hours, with only a 30 to 60% effectiveness rating. This procedure is not DTNA endorsed. Here are 2 excerpts from the Service Letter 14TS14 Rev, explaining why this process does not achieve optimum results. We strongly encourage you to read this letter in its entirety, as it contains other pertinent information. The second cleaning procedure is DTNA endorsed and involves a 3-step process applying heat, liquid, and air. This process not only removes loose ash, but hard-packed ash and oil coolant contamination. The result is 95% effectiveness with a service time of only 1.3 hours. The third solution is to simply replace the used DPF with a new filter. The service time for this is also 1.3 hours. This animation compares the effects of Detroit's cleaning process to the aftermarket process referred to as bake and blow. The filter on the left was cleaned using Detroit's process and has removed almost all of the particulate matter. The filter on the right, cleaned using the aftermarket process, only removes a portion of the particulates, leaving a significant portion around the outer edges of the filter. If the filter is cleaned utilizing the bake and blow process only when the CEL is illuminated, an overtemp may occur in either the DOC or the DPF. At this point, platinum is released from the coating and migrates to the SCR catalysts and contaminates them. The result is low NOx conversion efficiency, especially at higher operational temperatures, and possible replacement of the one box. Even if the bake and blow method is utilized at the DTNA recommended cleaning intervals, only 1 1/4 inches of particulates are removed. At the second cleaning interval, there is already 3 inches of particulates in the filter, because the bake and blow method used the first time left 1 inch of ash behind. Over time, this continuous buildup will increase the potential for damage because the ash level will never fall below 2 inches. The impact of inadequate DPF cleaning can cause irreversible damage. Ash pockets are dislodged from the exhaust end, but not discharged. These ash pockets create hot and cold zones, causing high thermal gradients, which leads to expansion cracking. The center of the filter expands and contracts with increased temperature variations. The temperature of the outer rim is much lower and isn't susceptible to extreme expansion variations, but is under high stress levels by resisting expansion from the center of the filter. This causes fractures in the rim of the filter, and because the rim is a brittle material, the cracking will propagate across the entire DPF immediately and cause some level of leakage. This table can be used as a quick comparison for each cleaning process. Please review the information carefully. Note that replacing the DPF unit is also a viable solution.